Okay, today we're going to be looking at our second case of solving triangles. In this case, we're given the measurements of 3 side lengths. In other words, all 3 sides, we know the measures of their lengths. Now, one thing that we learned in our previous work is the triangle inequality, and that is that the sum of, let's see if I can get all this to show here. Okay, and okay, so here we have a triangle, and if we are given a side here, and we have a side length here and one here, if these two are too short, what we're looking for is the last vertex has to be on the green circle and it has to be on the red one as well. Well, if they're too short, these two triangles don't meet, or even if they just barely touch here, there's no triangle possible. So when they just barely touch there, they're tangent to each other. That's when B and C added up together the same as A. So for there to actually be a triangle, the sum of B and C has to be greater than A. In fact, the sum of any two sides has to be greater than the third side. So in particular, look at the short two sides, and they must add up to more than the long side. But if that's the case, then there's exactly one triangle that we can make up. So if I pick up any side lengths I want, say 2 and 4, and now we need something less than 6 here. How about 5? How about 5? Then we get exactly one triangle with that side. And we should be able to figure out what the angle measurements are. We can also compute its area. And we have that. Now, how do we go about computing those angles? Well, the trick is to use the law of cosines. So once again, we have this law of cosines that says c squared equals a squared plus b squared minus 2ab cosine of c. But solving for the angle, we can do that like this. Subtract a squared and b squared. And then, well, actually, then multiply both sides by -1 to get this. Divide by 2ab, and then take an inverse cosine. And that will allow us to find angle C. And similarly, we can permute the letters around and solve for any angle. So we can use these 3 expressions to solve for the 3 angles, if we know the 3 sides. Well, that's exactly the situation we're in the side-side-side situation. So if I click on showing the computations, here we go, and we can use these to find it. And I'm going to use the angle sum to check. Of course, once we found the first 2 angles, we could have just used the angle sum at that point. Now, I'm wanting the angles in degrees, so I check my mode to be in degree mode. There we are. And so I'm going to actually store these values as A, B, and C. 2 store as alpha A, 4 store as alpha B, and 5 store as alpha C. Now this is maybe not so much help when they're just a single digit like this, but if these had a lot of digits, this could be helpful for us. And so we know to find angle A, it's an inverse cosine of, be sure you put parentheses around the numerator, b squared plus c squared minus a squared, close the parentheses on the numerator, divide by parentheses 2 times, we're looking for a, so we put b, and c in the denominator, close parentheses, and enter, and there's our angle in degrees. Now, if those were exact values for the sides, then of course this would be a decimal approximation for the degree measure, but it would be accurate out as far as the digits go. Of course, if those sides were measured to 3 significant digits, then the best we could do here was 3 digits would be 22.3 degrees. But here we see even more digits than is shown in the sketchpad sketch. Similarly, we can find angle B by doing inverse cosine, parentheses around the numerator, a square plus c square minus b square. Notice the angle we're looking for is b, then you need the minus on the b square. Divide by 2, and we need in the bottom we need b and c, but no, that's wrong. That should be 2a and c, and I have it right in everywhere except for one spot. Let me fix that. 2ac. Close the denominator, close the inverse cosine, and that's the correct answer. The only problem is right here. Let's see, right here, that should say a. And of course I did put in the value of a there, so that's correct. So anyway, there we go. And of course I can find the last angle, as you can see here. It's the inverse cosine of parentheses a square plus b square minus c square, close parentheses, divided by open parentheses 2, and I need a and b this time. I don't have c, the one that's opposite angle c in the bottom. And enter, and that's 108.2099569 degrees. And so we have those. Now, if I had stored these maybe as x, I can't do a, b, and c because I've got using those for the sides, but I could have stored these as maybe x, y, and z. And then I could have checked to see that x plus y plus z, or capital A plus capital B plus capital C, was 180 degrees, and that could be our check. And we can do that with the rounded off versions. Now the rounded off versions could be off in that last digit. The better check would be to use the other versions. But if I do this, this should turn out to be 180. And then to find the area, it's 1/2 AB times the sine of C. There should be a 1/2 right here. Okay, and alright, let's see if the number's right in the end. Should be 1/2 or 0.5 times A times B times the sine of angle C. Now angle C was that was this one, 108. So let's type all the digits in. 108.2099569. And again, it would have been better if I had saved that as, say, Z or something. So I didn't have to type all that in. And 3.799671038 square length units, in this case centimeters. So the final answer was correct there. Okay, so that's how you do a side, side, side. And like any of these work, if you go to the to this sketch and you go to the one that ends with a 2, so side angle side 2, side 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 2, angle side angle 2, angle angle side 2, side side angle 2, or even angle angle 2, then you have computations shown. So it uses law of sines, law of cosines, and the angle sum theorem to compute the missing information, what we call solving the triangles. So there's the side, side, side. What I would suggest doing is just making yourself up some numbers for the sides, see if you can solve it, and then come back to here and check your work. So if we made up a new one, well, here, you try one right here. We'll try it. Suppose we do, let's see, let's suppose we do a 3 centimeter, 8 centimeter, 10 centimeter triangle. Why don't you work that one out, and then we'll come back and check it here in just a minute. Press pause now. Okay, coming back, all we have to do is double click on that, type in 3. Come on, try again. Double click on that, type in 3 and enter. And then the next one was 8. Then 8, enter. And the last one is 10. And enter. And that draws it to scale. So if you were to draw it out, construct it, that's what it should look like. And then this readjusted all the calculations, so you should have come up with angles, A, B, and C opposite those sides, A, B, and C, of 14.36 degrees, 41.41 degrees, 124.23 degrees, and an area of 9.92 square centimeters. And so you can make up as many problems as you want to check and practice using this. This is a basic skill we should be able to do in our trig class.